All right, so as I read this, I'm going to highlight the important information. So the time required to deliver and install a computer at a customer's location is time equals 4 plus D over R, where T is the time in hours, D is the distance in miles from the warehouse to the customer's location, and R is the average speed of the delivery truck. If it takes 6.2 hours for the employee to deliver and install a computer for a customer who's located 100 miles, what is the average speed of the delivery truck? All right, so let's start solving this. I know that the time is 6.2 hours. 4 is a constant. The distance is 100 miles. And then I have R as the rate. So if I multiply everything by the common denominator, that would be R. So times R, times R, times R. I'm going to have 6.2R equals 4R plus 100. And this should have been a plus sign. All right, so now if I subtract 4R and subtract 4R, I will end up getting 2.2R equals 100. Divide by 2.2. So 100 divided by 2.2 gives me 45.5 if I round to the nearest tenth. So the speed at which this delivery person was driving was 45.5 miles per hour. Okay, so the problems are not always going to be this easy. This one gave you the equation and all you had to do is plug the numbers in. Okay, so now let's look at this. On a river, a kayaker travels 2 miles upstream and 2 miles downstream in a total of 5 hours. So we have 2 miles upstream, 2 miles downstream, and a total of 5 hours. In still water, the kayak can travel at an average speed of 2 miles per hour. Based on this information, what is the average speed of the current of this river? All right, so this might look kind of complex, but we are going to break it down here. So we have upstream and we have downstream. So most of these motion problems are going to use distance equals rate times time. So I've got distance, I've got rate, and I've got time. Okay, so what do I know? I know that when they go upstream, they're going to be going 2 miles per hour. However, I'm not sure what you know about kayaking, but when you're going down a river, the current actually goes downstream. So when I'm going downstream, I'm going to be 2 miles per hour, but the current is going to push me along. However, when I'm going upstream, it's actually going to slow me down. So in other words, the rate is going to be 2 minus the current because it'll slow me down, but downstream it's going to be 2 plus the current. And we know that upstream is going to be 2 miles and the distance downstream is going to be 2 miles. Okay, now you might say, well, I don't know the time and maybe you want to put 5 hours, but we're not quite going to put 5 hours here. So let's solve this for t. So the time is actually going to be the distance over the rate. So we don't even know, we know that the total time is 5 hours. So we know that if we add these two together, it's going to equal 5, but we don't really know exactly how long each one took because each one's going to take a different amount of time. It's going to take longer to go upstream than it is downstream. So if I take d divided by r, I do 2 over 2 minus c. And then here, if I do d divided by r, it's 2 over 2 plus c. So again, I set up this chart. I have distance, I have rate, and I have time. Upstream, it's 2 miles, and I'm going to paddle at 2 miles per hour minus the current. Downstream, it's going to be 2 miles, and I'm going to paddle at 2 plus c because the current's going to go with me. And in order to fill in the time, I'm just going to use distance over rate because I really don't know what each time is going to be. So now what I want to do is I want to say if the upstream time plus the downstream time is going to be equal to the total time, which is 5. So now I start solving this. Okay, so my common denominator is going to be 2 plus c, 2 minus c. So on this one, I can multiply by 2 plus c. This one, I can multiply by 2 minus c. And this, I'm going to have to multiply by 2 plus c, 2 minus c. All right, so therefore I now have common denominators, so I can get rid of that. So it's going to be 2 plus c plus 2 minus c equals 5, and I'm going to go ahead and FOIL this, so it's going to be 4, and one of these should have been a minus. So the outside and inside are going to cancel because they're going to be opposites. It's going to be minus c squared. All right, so let's distribute this and distribute this, and then I'll distribute over here. All right, so these are going to cancel out. I'm going to have 8 equals this. So now I can subtract 20. Divide by -5. So if I do 12 divided by 5, I will get 2.4. And now I just need to take the square root of both sides. And I will get plus or minus 1.5. I'm going to round to the nearest tenth. However, obviously a current is not going to go at negative 1.5. So the answer is that my current speed is 1.5 miles per hour. And when I say current, I don't mean like the speed at this moment. I mean the current of the river. So when you have a river, it flows downstream in one direction and the current is going at a certain time. In this case, it's going at a certain speed. In this case, it's 1.5 miles per hour. So that means if I'm trying to figure out how fast I'll be going, when I'm pedaling downstream, it's 2 plus that, so it'd be 3.5. If I'm going upstream, I'm going really slow at only a half a mile per hour, which would be extremely slow. So again, let's just go back up to the top and kind of review the process one more time. So when I have these motion problems, I'm going to use distance equals rate times time. You set up the distance, you set up the rate, and then the time is going to be the distance over the rate. And then you use those two, set them equal to each other, and say those two together equal the total time. And once you get that, the rest is just solving the equation, which I think you all can do. Just the hard part is setting the equation up.